The Robot Operating System is a middleware framework designed to manage hardware abstraction and message passing between different robotic processes. To understand how these processes communicate, we are going to build a custom ROS package and write a C++ node that publishes a live telemetry stream. To follow this tutorial, you must have Ubuntu 20.04 installed alongside the full desktop version of ROS Noetic. Because the ROS ecosystem relies on these individual nodes to share information, learning to create and compile them is necessary before moving on to complex tasks like autonomous navigation. We begin by setting up a dedicated compilation directory. Open your terminal and create the folder structure by typing mkdir-p ~/catkinwis/source, then move into that directory. Initialize the space by running catkin init workspace. Then move back to the root folder with cd ~/catkinwis and run catkin make to generate the environment. This diagram shows the resulting file system layout. The root workspace now contains build and del folders, which handle the background mechanics of your compilation. For your terminal to recognize this new workspace, you must execute source delv/setup.bash to update your current environment variables. This isolated workspace allows the system to manage code and resolve dependencies without modifying your computer's core operating system files. Now we will generate the package. Ensure you have navigated back into the source directory before running the creation script, or the workspace will not compile correctly. Run catkin create package, custom robot control, std messages, ROS CPP, ROS Pi. This command names your package and explicitly links the libraries needed for C++ and Python communication. Inside this folder, you will find two specific files, package.xml and cmakelists.txt. In ROS, a package is the organizational layer that bundles source code with its specific metadata and dependencies, allowing the system to treat your code as a single shareable unit. Inside your package's source directory, create a new file named talkernode.cpp. This C++ script defines the logic for our node. It handles everything from network registration to data broadcasting. The ROS.init function is the first active line. It formally registers the name talker, so other processes on the network can identify this node. The nh.advertise line establishes a topic, a named databus that allows this node to broadcast information to any other process listening on the chatter channel. A while loop keeps the process running, incrementing a counter and formatting that number into a standard string message for each cycle. The publish command then sends that formatted string out onto the active topic for the rest of the system to see. This entire script creates a node, a modular executable process dedicated to the single task of broadcasting telemetry. To turn this script into an executable, you must modify the cmakelists.txt file located inside your package folder. Make sure you are editing the file within the custom robot control folder and not the global file at the root of the workspace. At the bottom of the file, add executable to define the target name and target link libraries to connect it to your ROS libraries. These instructions tell the catkin build engine exactly how to compile your code. Without them, the system will not find your node at runtime. Return to the catkin root and run catkin make. This triggers the compiler to build your new node based on the instructions you just provided. Run the source dev setup.bash command again to ensure your terminal environment is aware of the newly compiled executable. Now open a second terminal window and type roscore. This diagram illustrates the ROS master. It acts as a central lookup service that nodes use to find each other. Without the master active, individual nodes have no way to establish the peer-to-peer connections required to share data. With the master running, your network is ready to host the telemetry node. In your first terminal, launch the node by typing rosrun custom robot control talker node. You should see the terminal begin to scroll with information. This confirms your node is successfully broadcasting its telemetry payload across the network. You have now initialized a workspace, configured a custom package, and programmed a node to communicate over a ROS topic. Currently, this node is broadcasting to an empty network. In our next tutorial, we will build a subscriber node to capture this stream and visualize the data.